automation systems rely on more than just immediate reactions. They require precise management of duration and quantity. This is the domain of timers and counters, fundamental building blocks in programmable logic controllers, PLCs, and digital control systems. Timers manage how long an action persists, while counters track occurrences. Mastering these components is essential for reliable process control. A timer, T block, possesses critical elements: the preset value, PV, defining the required duration, the accumulator value, ACC, showing the current elapsed time, and the enable, EN, and done, DN, bits. The timer begins accumulating time when its input condition is met. EN equals 1. Once ACC equals PV, the DN bit sets to 1, indicating timing is complete. The on-delay timer, TON, is the most common mode. Its purpose is to delay the activation of an output. When the input condition, EN, is satisfied, the timer begins accumulating time. Crucially, the output, DN, remains off until the full preset time has elapsed. If the input condition drops before the time is complete, the ACC resets immediately to 0. Consider a conveyor system that requires a 5-second pause after a start button is pressed to ensure all safety guards are down. The TON block is initiated by the start signal. During the 5 seconds, the system is inert. Only upon expiration does the DN bit close, energizing the conveyor motor. This creates a clean, intentional lag. The off-delay timer, TOF, handles systems that require a sustained action after the initiating condition is removed. When the input, EN, goes high, the output, DN, immediately goes high. The critical difference: when the input goes low, the TOF starts timing. The output remains high for the duration of the PV, then drops low. A common TOF application is cooling fans. A machine may shut off, but the fan must run for 30 seconds more to dissipate residual heat. When the machine power, EN, is removed, the TOF begins its count. The fan, DN output, remains active for 30 seconds, ensuring proper cooldown before deactivating. Counters, C, are analogous to timers but track discrete events rather than elapsed time. They track how many times a specific input condition is met. Like timers, they have a preset value, PV, an accumulator, ACC, and a done DN bit that sets when ACC reaches PV. The CountUp CTU instruction increments the ACC value every time its counting input receives a trigger, typically a positive edge transition. Once the ACC reaches the PV, the DN bit is set, indicating the count limit has been reached. To reuse a CTU block, a separate reset R input must be pulsed, which forces the ACC back to 0. The countdown, CTD, decrements the ACC value upon receiving a trigger. Often, CTU and CTD are combined into a count-ups-down, CTUD block, allowing for flexible inventory control where items are tracked both entering CU and exiting CD system, maintaining a net total in the ACC register. Timers and counters provide the essential temporal and quantitative logic required for advanced automation. Whether ensuring a safe start sequence with a TON, extending cooling time with a TOF, or managing inventory with a CTUD, these precise components form the backbone of reliable and safe industrial control systems.